I'm so excited. Today is Valentine's Day, and you should be, Valentine's Day is the day of love, right? So where did I come in? To the Academy. Why? Because I love the Academy. This is the place that makes me whole. So where else would I be on Valentine's Day, huh? I'm actually getting kind of hungry. Yesterday I went to this place in Hampstead, coffee shop called the Feng Shui House. Check it out. Yeah, look it up. The Feng Shui House, also known as the Jelly Bean. It was awesome. I had a breakfast sandwich on an osteoporosis bagel. It was great. And, I'm so excited. I think I should go back there again, but no, I got to make this video. So let's get this done. What's the video on, you ask? The video is on sound intensity. Sound intensity, loudness, okay? Loud is a human perception. I mean, sound has intensity to it. If sound has intensity to it, if you have bad hearing, you might not be able to hear it. Or if you have, like hearing like mine, you can only hear certain frequencies. But the frequencies happen and they have an intensity to them. And whether or not it's loud to me or not loud to me is based upon my hearing. So loudness is human perception of intensity. Okay, intensity is like poop. It happens. Loudness, maybe not. It depends. It's kind of analogous also to earlier, last week, we talked about pitch and frequency. Frequency happens. Pitch is human perception of the frequency. You with me? Okay, good. Let's get going. So here we have, now you can get the notes out, on the third page of your wave sound notes. This is the stuff that I'm going over right now to wrap up this unit. Make like a tree and wrap it up. Yeah, you think about that one. So now this says, this is sound intensity. And I put RI, not for Rhode Island, okay? Smallest state, by the way. But if you're in the middle of Rhode Island, you drive 20 minutes in any direction, you're out of the state. Yeah, that's pretty small. So relative intensity, that's what that means, relative intensity. Now, what do you mean relative intensity? Okay, well, we'll get to that. But for now, this is going to be a loudness scale. This is really what this comes down to, a loudness scale. And this is going to be measured in decibels. You've heard of that, decibel, bell, named after who? No, not named after who. It was asking the question. Never mind. Alexander Graham Bell. Did you know that the first words spoken over the telephone were Alexander Graham Bell was talking, well, he spoke, his assistant, Watson was his name, and he picked up the phone, and Alexander Graham Bell needed him, so he said, Watson, come here, I want you. Okay, a little weird, but that's what he said. And those are the first words, Alexander Graham Bell, okay, after him, the telephone guy. So the bells, decibels, now decibels, okay, decibels, okay, so that of course is a prefix meaning 1/10. So this equation, to put it into decibels, if we take the 10 out of the equation, we have bells. But we multiply it by 10, we get decibels, okay? You with me? Because deci is 1/10, so you multiply by 10, you get bells. Anyways, that's what the 10's in there for. So we go from, without it, we'd be bells. With it, we're in decibels. Okay, so decibel scale, let's take a look at it. Again, upload it into, I put it in Google Classroom, it's out of the book. Got it there for you, and so you can take a peek at that. You have it. And this is a combination of that one that I put in for you, which is actually out of the G and Coley book, the book that we usually use. And I put a couple of others in there that I knew I wanted to talk about. So these are the relative intensities of the sounds that we hear. And a lot of these are kind of daily sounds, or you're all familiar with them. And so what does the scale mean? How does it work? For example, if I look at mosquito, I put that one in. That's mine. Mosquito, 20 decibels. As opposed to a lawnmower, I put that one in. Me. 80 decibels. What does that mean? Does that mean that the lawnmower is 4 times as loud as a mosquito? Oh, does that mean, in other words, saying that, does it mean that if you had 4 mosquitoes, it would be as loud as a lawnmower? Come on, that's not true, right? So this is a relative intensity scale, logarithmic, boom, 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 log scale. So no, 20 and 80, it doesn't work that, 4 mosquitoes would be equal to a lawnmower. It doesn't work that way. Okay, it's log base 10, so let's go through how that works and what's this equation all about, Charlie Brown. Okay, so to be on the decibel scale, boom, you've got to go through this calculation. And I all right, is intensity. And intensity, sound intensity, is the amount of watts per square meter of surface. So if you have a square meter about yay big, and you zip it with 1,000 watts, a really powerful stereo would be 1,000. It could be a super powerful stereo. Actually, a powerful stereo is 500 watts. Your car stereo, most factory car stereos are around 100 watts. So we're talking like boom, 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 boom. Yeah, 1,000 watts. It would be 1,000 in a square meter. Okay, that'd be 1,000 watts per square meter. It's an intensity measurement. Now, this down here, so that's I, intensity. Down here is I-O, it's off to work I go. I-O is called the threshold of human hearing. Okay, human ears, pretty good. They can have a lot of different range of sounds. I go like 20 hertz to 20,000 hertz, like a huge range of sound. And very, very like Elmer Fudd, killed the rabbit, I killed the rabbit, killed the rabbit, killed the rabbit. I'm back. I didn't kill the rabbit. It wasn't quiet enough. He ran away. Okay, so this is the threshold of human hearing. If you have very good ears, you can hear this sound intensity. That's what I call the threshold, like the bottom, quietest thing you can hear. 1 times 10 to the negative 12th. Think about that number. That's small. Negative zeros, 1, 2 watts per square meter. Okay, that is a relatively large area and a very, 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 very little amount of power. Okay, remember, watts are power. This is power. So the way we look at this is power per square meter. Because remember, watts are power. We remember that. Yes, you do. Yes, you do. We all know. So this is a very small amount of power. It's a very, very quiet Elmer Fudd-like sound. So that is a constant. That goes in here. Okay, you don't have to memorize it. It'll be provided for you. Okay, if any assessment, yeah. So this is a constant value that goes into the equation. Now, this can vary. How many watts are you cranking out? And what is the surface area we're talking about? Okay, so that can vary. This is the log 10. All you have to do is have a calculator with a log button on it. Nailed it. You even have to know that logs are exponents. All they are is exponents. But you don't have to know that. You just have to have a calculator with a button, hit it, got it, good, all right. And this is, 10, so multiply it by 10, gets you from bells into decibels. Okay, so now, let's take a look at our chart for a minute. We'll come back, we'll do a problem here. Let's look at the chart. So let's go back to the mosquito and the lawnmower. The mosquito being 20 decibels, and the lawnmower being 80. What does that really mean? On a base 10 log scale, sounds smart. Every 10 that you go up in intensity, or in decibels, is a 10 times the intensity. 10 times the intensity. So every time I go up by 10 on the decibel scale, I'm going up in intensity by 10. Okay, all right, seems okay, all right. If I go from 20 to 30, all right, that's mosquito to a whisper. Hello, hello, hello. If I do that, I've gone up 10 times its intensity. Okay. If I go from a mosquito to a lawnmower, every 10 is 10 times more intense. So if I go from, 20 to 30, that's 10 times more intense. 30 to 40, 10 times more intense. 40 to 50, 50 to 60, 60 to 70, 70 to 80. Okay? That is 10 to the power. So that's 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000, times a million. Awesome powers. Awesome. That means from here to there, that's better. That means that we have a 1 million times as intense. Oh, I don't need that one. A million times as intense of a sound. Okay, so the intensity is a million times. What does that really mean? Remember earlier I said, well, what does it mean? You have 4 mosquitoes at 20, you're going to equal a lawnmower at 80. 4 mosquitoes do the... No. How many mosquitoes would you need? 1 million. If you had 1 million mosquitoes, 1 million times more intense. So if you make the... You need every 1 million times more intense. You need 1 million mosquitoes to do that. Now, if you had 1 million mosquitoes buzzing around your head, you're going to have a lot more problems than the lawnmower sound. It's going to be loud. You're going to whoa, whoa. It's going to be a bad day for you. A lot of mosquito bites. Don't scratch them. Don't get infected. Okay? All right. So that's what that means. So we take a look over here. We have rock concert and TOP, the threshold of pain. This is where, for most people at 120 decibels, you're going to be going, ow, 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 ow. Okay, been there, done that. Okay, been there, done that. Nasty, nasty stuff. I've been to a lot of concerts, and that's why I can't hear anything anymore. And high frequency stuff, 16,000, put above, gone. Some of you were in class last week. I was playing around with the tone generator, having fun, making you all in pain. It was great, but I couldn't hear it. I mean, 16,000 and got nothing. Well, why? Because that loud, intense sound at the threshold of pain does damages to the cilia that are inside of your ear that pick up those high frequency sounds. So, yeah, if you go to AC/DC, for those about to rock, we salute you. Yeah, you better bring your earplugs. All right? So the 120 decibels, you know, how much more intensity is there than the mosquito? Well, at 80, we're at 1 million. Let's go to 90, it's 10 million. Let's go to 100, it's 100 million. Let's go to another 10 times more than 110. That's 1 billion, 10 billion. It's 10 billion mosquitoes louder or more intense than, whew. Now, here's the thing, though. I'm going to say more intense. The intensity goes up by 10. Okay, this is important. Pay attention, okay? Listen up. Stop drooling and wake up, doggone it. Wake up. Are you awake? Okay, you need to know this. You'd better. Okay. Every 10 that you go up on the scale is 10 times more intense. Oh, that means it's 10 times louder. No. What? No. Every 10 that you go up is 10 times more intense. However, the ear hears it. The ear is pretty awesome. It hears it as 2 times as loud. Okay. So if you go up 10, so you go from 0 to 10 on the decibel scale, this is 10 times as intense, but 2 times as loud. It's perceived as twice as loud. Okay, now let's go back to mosquito and lawnmower. The mosquito, okay, is, you know, the lawnmower is 1 million times more intense, but it's not 1 million times louder. Actually, going back to earlier when I said that, it is 1 million times more intense. But how many times louder is it? Every 10 that you go up is twice as loud. That's how we hear it. Okay, the intensity's there, but it goes up twice as loud. There is a section in your book, for a few of you who have taken the book out, you can actually read about the anatomy of the ear, and it's like called biophysics. There's a field called biophysics, kind of combine the two. Physics is better, biology's down here. Biophysics, okay. It's here. So, but it does have physics in it at least. And it talks about the ear and how it actually does the job to do that. It's quite an interesting read. Do it. Check it out. So this is how many times louder. Okay. That's at 20 to 30, 2. 30 to 40, 40 to 50, 50 to 60, 70, 70, 80. Okay, so 2 to the 6 pow. Okay, not 10, but 2 to the 6. Okay, 2 times 2 is 4, times 2 is 8, 16, 32, 64 times as loud. 64 times as loud would be your lawnmower. That's how we hear it, we perceive it, than the mosquito. 1 million times more intense. I forgot what I just said. 64 times as loud. Okay, so that's how the decibel scale works. Every 10 that you go up, the intensity multiplied by 10. The human ear hears the loudness multiplied by a factor of 2. Okay, so 2 times 2 times 2 times 2. All right, let's see. Let's get into solving a problem yield this equation here. But we'll stop this video right here, all right? And this is the theory behind it. We'll stop the video, then we'll come back, take a short break, and we will do a problem-solving video thingy. Okay, BRB.